Now you may be wondering that every device needs an IP address to communicate. Who assigns this IP addresses? And that is where DHCP as a protocol comes into picture. DHCP is a protocol same like DNS which exists into the TCP/IP stack, and this protocol's use is to assign IP addresses to devices who request for it. That is why it is called dynamic host configuration protocol. It automatically dynamically configures the host who reach out and seek an IP address for communication. Let's go ahead and discuss what is DNS, how it works actually. Let's talk about behind the scene logic. I am keeping information at high level, not getting into every single detail, but good enough information to get you started. So let's consider these are all my clients who are connected to my network. Now, this network could be a physical network like we see here, there's cables, or it could be a Wi-Fi network, doesn't matter. These devices would require a network interface card or NIC in them. You call it network card, Ethernet card, Wi-Fi adapter, but that is all the network equipment you need for communication. So most of our laptop or maybe mobile have this Wi-Fi component by which they would be requiring and getting an IP address. Now, when these devices connect to a network, they do not have any IP address. There is no default IP address for any device. So what we do in this case, either I could go ahead and in every device configuration, I could manually configure the IP address. If it is 2 or 3 computers, it is easy. But if it is 100, 200 computers, 2000 computers, I have to go and manually assign. What if there is a conflict? So that is not very sustainable or scalable model of manually assigning IP address. So what we do in our network, we set up a DHCP server, dynamic host configuration protocol server. This DHCP server could be a standalone server which is doing only that stuff, or it could be that a server having other component plus DHCP service installed on top of it, or it could be built in into a hardware device like a router or a switch, or it could be into a software or a virtual machine. It depends what you want. So DHCP server is a component who is responsible for listening to the request and then providing the IP addresses. What we do in this DHCP server, we associate a IP address pool with it. Pool is a group of IP addresses. Like here I said DHCP server, I am allowing you to have address of 10.0.0.1.0 up to 100. So it is allowing, we allowed this server to have 90 addresses to be distributed to client who requested, and this information would be stored in a database of this particular server. So when this particular client starts, at the very beginning it would send something called a broadcast. It basically a call for help. Client starts up, powers on, and it says, hey, I am a client and I do not have an IP address. Can somebody provide me an IP address? So that broadcast, as the name says, is listened by everyone who is connected on the network. This would listen, this would listen, this would listen. But these clients do not have DHCP server component running, so they won't be able to respond anything. They just hear it. But this server here has DHCP services installed. So it says, okay, I am a DHCP server and I can give you an IP address. Let me figure out what I can give you. So what it will do, it would be keeping a database to ensure that it is not duplicatedly giving IP addresses. How it uniquely identify these clients? So every client would have a MAC address associated with it. Whether it is a Wi-Fi or whether it is a network physically connected, they would have a MAC address, media access control address, a physical address embedded into the system, into the network card. So let's say this address of this MAC is ABCD, this one is PQRS, and this one is XYZA. This information is used to capture in detail of that client, and now my DHCP server says, okay, a user came in or request came in from MAC address ABCD. I assigned him IP address 10.0.0.0.11, and this is assigned for a lease. So depending on what configuration you have done, your DHCP server would be leasing the IP addresses, not permanently giving to them. So these addresses are leased. Second client starts PQRS and that gets IP address, let's say 10.0.0.15, and its lease can be different. You could configure these parameters, should not be a problem. Third client comes in. Let's say this was my client XYZA, and now XYZA would be getting an IP address, and that can be something, let's say probably it would be sequential, but again there can be n number of things which could decide whether you will get 16 or not, and through that now this machine has an IP address available. So that is how the basic mechanism of DHCP works, dynamic host configuration protocol. It listens to broadcast coming on network, and based on those broadcasts responds with a offer for a IP address, and then client can accept it or reject it, and then it can use that IP or may not use that IP, it depends. This DHCP server not only assigns these basic IP addresses, but it also gives the client additional information, whatever you have configured here, right? So you have configured here additional parameter like, okay, give this user DNS address, gateway address, domain name information, so that this client is well aware about all the network. So let's say you go to a tourist office and then you ask for a ticket. With ticket they can give you a map also, so that you know that what areas you would be able to explore or what options are there for you to go from point A to point B. So that is the same thing. It may not be just the IP address, but additional parameters can be given to these clients so that they automatically get configured. This process is also known as DORA. What happens here, let me quickly brief you on that. So first thing happens is a request. So this DHCP client starts and says, hey, I don't know anyone. So it sends a broadcast to IP address 0000, which is a broadcast address, and that request is called DHCP discover. That I am looking for a DHCP server. Is there any server? And if DHCP server is there, it would say, yes, I am a DHCP server and I have this offer for you. I can give you, let's say, IP address of 10.0.0.16. You may be thinking, what happens if there are multiple DHCP server on the network? Yes, it can be, and then that's why DHCP client may decide which offer it wants to accept. Most of the time it would accept the offer which is received the first, but if there are multiple DHCP server, this client can get multiple offer, and then maybe it would select one and reject other one. So once this client decide which offer I am going to accept, it goes to DHCP servers and say, okay, thank you for giving me an IP address. Yes, I am interested. Can you please assign this IP address to me? And that happens in a request. And while this happens, what also happens behind the scene, this information is also being sent to everyone in a way so that other DHCP server now back off and say, hey, this client has already requested an IP, which means it is going to be associated or getting the IP from this DHCP server. We do not need to worry about it anymore. And then they do their own work. So this client here says, yes, I'm happy and I want to request this IP address, and now this DHCP server says, okay, done, this is going to be your IP address, I acknowledge it, and that time the entry is made into the database of DHCP. So that is on high level how DHCP works, ensuring that every device gets an IP address. So in most cases, I would say 99% cases nowadays, you do not need to worry about assigning these IP addresses manually. It is done by cloud providers, or you could set up your own DHCP in case you need, and you can have multiple servers also, and multiple client can have multiple IP addresses assigned, should not be an issue. So I hope this has given you a little bit more idea on what DHCP is. Thank you.